Okay, we are back live, guys. Sorry about this. Turns out when I'm running this particular line of code with the LID detector, everything just freezes, which is weird. I have to restart my system. So when I run like model predict, everything just goes to hell. Okay. So let me restart I go to Stopes. Unfortunately, I keep on losing my work. So I'm just going to delete this directory and run it again. And so just run the filtering again. Make sure this starts running. Okay, go back to FairSec. So apparently label and then language code is how this looks like. And that's precisely what we've seen as well here. Word representation, learning text classification. So it can be trained to train supervised text classifiers, for instance, sentiment. In order to train, described in this paper, we have to do this, where train.txt is a textual file containing a training sentence per line along with labels. By default, we assume that labels are words that are prefixed by that string label. This will output two files, model bin and model back. Once the model was trained, you can evaluate it by computing the precision and recall at k on a test set using this. Let me just see if everything is working. Okay. Where test.txt contains a piece of text to classify per line. In order to reproduce results from the paper, run classification results sh. Okay, so that's fast text for you. Do they have any documentation? I would love to use, instead of using it like this, I would love to use it a bit as just like a Python function instead of this. This is probably being called from the command line or whatnot. Let's see where we have Python. Sorry, fast text. So on the activate NLLB, Python import fast text. Yes. Text classification. Python. This is what I wanted. Fast text train supervise, and then we just pass in the file. So we get the model. We can save it, and we can test the classifier, predict. Making the model even better. Okay, changing the default parameters. Looking at the data, we observe that some words contain uppercase letter or punctuation. One of the first steps to improve the performance of the model is to apply some simple pre-processing. A crude normalization can be obtained using command line tools such as streaming editor and TR. When we were training the previous one, this cooking train, where can I find this file? Guys, I'm gonna make just a quick break and be back in a couple of minutes. Okay, already back. Let's see where we stopped. trying to find the data. These examples they're using, is there any place where they're using it? Crawl, docs, Python, scripts, tests, blah, 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 blah. Do they have any txt here? Only this one. Just open up a ton of these directories and see what they've got here. Source, Python, docs, scroll. Examples maybe. Training to supervise. Print the results. Train data from the environment. Cooking train. That's what I'm trying to find. Is this checked in somewhere or what? It definitely doesn't seem to be checked in. Okay. Let's go to the advanced reader section. Making the model better. Okay. Some words contain uppercase. Okay, I found it. So labels first and then text. Excuse me. Contain uppercase letter or punctuation. We definitely have punctuation. I'm not seeing the upper case letters. But okay, whatever. Let's see how we can improve the model. One first step to improve the performance is to apply some pre-processing. A crude normalization can be obtained using command line tools such as streaming editor and tr. So we dump the content, we pass it here, convert it into lower, and then grab and split that into train and validation, and then train the new model. And then test. More epochs and larger learning rate. By default, the fast text CZ training example only 5 times during training, which is pretty small given that our training set has only 12K examples. Can be increased using the epoch setting, okay. Let's test the newest model. This is much better. Not sure how to interpret this. 3000 lines, 0.5. What do we have as the second? What we have as the third element of this tuple? This tutorial sucks. Even better. So this is maybe precision recall or something. Word engrams. So what's the default here? So precision is the first field, I guess. We were initially, what, 12? $12.4 to 59.9. Pre-process the data, change the epochs, learning rate, and word engrams. What is a bigram? Unigrams are words. Okay, scaling things up. Multi-label classification. When we want to assign a document to multiple labels, we can still use the softmax loss and play with the Let me just see whether this is running. Seems it's hard. It seems it's running. My brain is glitching, guys. Okay. Multi-label classification again. Let me see what this section is about. We can still use the softmax loss and play with the parameters of prediction. Enable the number of labels to predict and the threshold. Using dependent binary classifiers for each label. One versus all. Not sure what bucket means. Bucket kind of just appeared all of a sudden. And dimension as well. Okay, can we have a bit more details then? Let me see, list of options maybe. Context window. Let me see one thing. How is this one trained? Just create an issue. Diagrams. One by default. Not sure what bucket means. Learning rate. Size of the vector. By default it's 100. But here it's 50. Let's analyze those past text models, see how they were trained. Size of the context window 5. Epochs. Loss. Okay, they have some auto-tuning options there. Nice. Okay, let's try and train some of an example fast text model. Or let's see whether there is some good blog on this topic. Okay. Let's check a couple of these. And let's also see whether the paper mentions something about training the model. I think they did. Fast text. And then the results. Language identification. Okay, we can do this tomorrow. Okay. Let's skim through this notebook. Okay, context size, if we increase this, we'll probably be slower but more robust, so we probably want to do that. I care less about speed, more about quality for HBS. Initial number of buckets for the n-gram hash table. What's the default? Or the 3 seconds to train. And then they save. Okay, this is going to be valuable for tomorrow. Very much valuable. We'll use this tomorrow to understand how to train this and analyze it. Let me see how big are the models we are using. $1.2 gigabytes is this one. And then there is the one model path. Let's quickly run this. Hopefully the system doesn't glitch again. Let's just see the model path. That's all I care about. Stop the run. .2 as well. I guess that has to do because we're supporting so many languages with these two. Over 200 languages are supported. When we load it, let's just see. Let's see what is offered. Which functions can be called on this model. Let's see something like this. What can we call here? LID model labels. Words, get analogies, get dimension. Two 256. Okay, that's the size that they've used. Get analogies. Get input matrix. Get the shape. $1 million. Yeah, that's why the model is so big. Get the input vector. It should be probably 256. Okay, these are just values. Get label ID, get the labels. And this should be probably 202. Actually, even more, 218. Labels. Get the line. What does get line do? Get the line. Tokenize it or whatnot. Get subwords. Okay. get the word vector, get the words, words. How many do we have? Was this the same number as the size of the matrix? Can we figure out how many context length? What's the context length? Get dimension, get input matrix. Get the label ID and get the labels, get the line. Let's get the line again. Let's get meter. Get nearest neighbors. Nice. Probably uses like something like cosine similarity to find the closest embedding vectors. Get the output matrix. What's the output matrix? Interesting. Y218. Get sentence vectors. Get subword ID. Okay, that's all I could extract from it. We'll continue with this tomorrow. I want to train a model for the HBS versus non-HBS data. And because this is so fast, we definitely need to do it, even for the first iteration. Let's see how this is progressing on the other hand. So we are still running here. Let's see the charts. Okay. Some progress on all fronts. Nice. Okay guys, with this I'm wrapping up the stream. I'm already super tired, and then we're gonna continue tomorrow, see what we get as a result from our filtering job, and also start training the fast text model for HBS data. Bye bye guys, have a good night, have a good day or good morning wherever you are, and see you tomorrow. Cheers. Fadil, I'm building our replication of the No Language Left Behind project. Check out come to the channel, to the Discord channels to get more information about the project. Let me see whether I can open up. Why is my Discord not opening? Okay. Yes, just join my Discord server and you'll find the information there. Hope that's helpful. So just this channel here, open NLLB channel inside of my server, which is Aleksa Epiphany. Good night, bye guys.